Alright, gang, this is section 2.7, and it's going to cover something called box and whisker plots. So find this handout, whether it's clearly labeled as our 2.7 notes or not. Find the one that starts out like this, and we're going to do a couple of different. We're going to do this handout, and then we're going to do this handout, which starts off looking like this. But anywho, we start off on this handout where it says, consider the following stem and leaf plot. So what we have here is what we call a stem and leaf plot, where we're giving you a list of numbers in a certain way, and over here is what we would call the stems, and over here would be all the leaves, so to speak, for this stem, and these would be all the leaves that all go with this stem. And so, I mean, we would have like 300, so that's 300. 302, 302. 304, so 305, 305, again, 306. So essentially this is 300, 302, 304, 305, 305, all the way to 309. And then down here, this would be 311, because 311. And then it would be 313, 313, 313. So, and this would end up being 317, so 317. Down here, this would be all the 320s, so 320, 322, 323, 325, 326. And so it's just a different way to list all of the data scores rather than listing them out, I don't know, I guess the long way. This is a slightly shorter way to do it. And so there ends up being 23 data scores, 300, 302, altogether there's 23 of them, all the way to 329. And so to list them, well, there it is. I mean, in case my loose description of a stem and leaf plot wasn't doing it for you, this is all of the numbers, 300, 302. And what's in blue here with the circles and the brackets, don't worry about that just yet. We'll get to that in a second. So for right now, just see that it goes 300, 302, 304, all the way to 326, 328, 329, and they're all represented here. So the next thing is, what is the mean? This is a callback to section 2.6. We just got done with that section. And the mean is the same as the average. So we would add up all of these numbers and then divide by 23 to get a mean of 313.74. The median, okay, that's where these blue markings start to come into play. Remember, the median is like the middle number. And so if there's 23 numbers, the way it would end up would be if you had like 11 numbers as like your bottom half, and then 11 numbers as your top half, with an actual one of the numbers being in the middle. So here's our median, this value of 313, which splits the data in half because there would be 11 numbers lower, well, not necessarily lower, right? Because look, tie, one of these numbers is the same, but so I guess you should say like 11 numbers to the left of this one, and then 11 numbers to the right. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the median is 313. The mode, if you recall, what am I doing? The mode, if you recall, is the number that occurs the most. And I'm going to go ahead and say that it looks like 313 is also the mode because we had 3 of those. And then the range, people, oh well, I guess really quick, this pertains to the mean, right? Now the range, do you remember what the range is all about? The range is all about the span of the data. It's the difference between the lowest number and the highest. So it's just some simple subtraction. 329 minus 300, that's real easy subtraction. And so that gets you a range of 29. So all that is review from last section. But the next question, or the next couple of questions, or series of questions, you may have never done this kind of thing before. You may have never heard of the lower quartile before. Well, here's what the lower quartile is. The lower quartile is one way, it's one name. Another name is lower median. And if that wasn't enough, there's actually another way to say this. First quartile. I sort of prefer lower median because it describes it the best in a way you'd understand. So the lower median, people, is kind of like this. When you find the median, whether the median is like one of the actual numbers or whether you had to go like in between a couple of numbers, whichever way, the median cuts the data into like 2 halves. And you have a lower half and you have an upper half. And so to find the lower median, which is also the lower quartile and then the first quartile, all you really need to do is find the median of just that lower half of the data. So the lower half of the data is only from 300 to this 313. And so finding the overall median of that half, since there's what, 11 of those numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, it makes sense to go 5 numbers, and then you'd have your median, and then another 5 numbers, which makes 306 in the middle of just the lower half. And so the lower quartile, aka lower median, aka first quartile, is 306. And likewise, the upper quartile you can also refer to as the upper median, which it can also be referred to as, be careful here, the third quartile. Again, like I would prefer upper median because it clearly describes, why do I keep doing that? It's clearly describes how you just look at the upper half of the data from here to here, and you find the median of only this part, the upper half. And so you're finding like the upper median of like the upper half. And it turns out to be 322. All right? So that's essentially what the lower quartile is and what the upper quartile is. It's another way to say just the lower half median and the upper half median. You know, so I guess to quick summary, there's the overall median, and then there's the median of just the lower half, then there's the median of just the upper half. All right? Because we need to move on now to the last question here, perhaps, and it's the, what is the interquartile range? Maybe you've heard of that before. I don't know. What is the interquartile range? Well, I mean, it's got the word range in it, but it's not like, so it is like a range. It's a range of something. It's not the entire range like we took care of here. This was the overall entire range. This is just the interquartile range. And to cut to the chase, to find the interquartile range, we're going to subtract these two numbers, the lower quartile and the upper quartile. And so it is like a range, but we're not going to subtract the numbers we did here. It's just going to be like the upper quartile minus the lower quartile. You might want to actually write this down. Upper quartile or upper median minus the lower quartile or the lower median. And so that brings us to actually like the bottom line here. It's like the grand finale. I guess we were building to this all along, drawing a box and whisker plot. This is huge on the Keystone exam. Knowing your way around a box and whisker plot. So, what do we need to know here? Well, a box and whisker plot, essentially, well, let's just cut to the chase, I guess. You're gonna draw a box that starts at the lower quartile, ends at the upper quartile, so 306 and 322, and we're going to draw a line in that box where the overall median is. So, excuse me as I jump back and forth a couple more times here. The first thing you need to do is you need to have a number line. So you can't draw a box and whisker plot without a number line to line it up with. Okay? And considering that my numbers went from about 300 to 329, notice how I scored up my number line. Okay, it looks like I went all the way to 330, and I spaced this out pretty good based on the numbers I was working with. And so, let's see, lower quartile, 306. So we got 306, 313, 322. 306, oh my gosh, yeah, I'm going to have to, so let's see, if that's 310, does this go 2, 4, 6, 8, yeah. So it looks like I'm going by twos, aren't I? So that would be 302, 304, 306, 308, 310, and then 312, 314, 316, 318, 320, so on and so forth. So it looks like we're making jumps of 2. So there again, we're going 306, 313, 322. 306, 306, 313 would be there, right? And then 322 would be exactly there. So again, a box and whisker plot contains a box that starts at the lower quartile, 306, ends at the upper quartile, 322, and we draw a line in the box wherever the overall median is. So lower quartile, overall median, which by the way, you can also call this the second quartile. If this is the first quartile and this is the third quartile, so many names, you can actually refer to the overall median as the second quartile. But that's how you go about drawing the box. It lines up with those measurements. And then we draw a whisker out to the lowest value, which in this case is 300. And we also draw another whisker, kind of like a cat whisker, all the way to 329. That was the highest value, right? 329, yep. So that's basically, people, how you draw a box and whisker plot. You have to know the lower median, the upper median, the overall median, and you have to know the absolute lowest number in your data set. So you can take a whisker out to there, 300, and the highest number to take a whisker out to there. And that's a box, those are box whisker plots. So moving on, what you might want to do on your own, all right, is try these examples on your own. On this handout, this separate handout that I'm moving on to now. But I'm going to run through these for you in case you need some extra remediation, or if you're just like completely absent, or if you want to pause the video, try all three of these and kind of see if you were able to do it correctly. You know, you may do that. You may pause the video now. But here we go. So if I want to draw a box whisker plot, I need, first of all, the median. And now remember, to find a median, these numbers need to be in order, which they look to all be in order, don't they? They look like that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 values. Let's check that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 values. So that what that means to me, since it's an odd number of values, there's going to be like one of the actual numbers in the middle, and then there'll be like 7 on either side. So 1, 2, 3, 4, 5, 6, 7. That would be the actual median, and then we'd have like 1, 2, 3, 4, 5, 6, 7 more. So here's my upper half. And if there's 7, that means to me there's going to be 1, 2, 3, the actual upper median, and then 1, 2, 3. Same thing in the lower half. 1, 2, because there's 7 of them. 1, 2, 3, and then that guy, and then 1, 2, 3. So there we go, people. There it is. So the lower median is 103. So let's look down here. Look at the way I labeled my number line based on my span of numbers, you know. So let's see, it looks like that would be 95, and that would be 105. You know, so it looks like my little hashes are going by 5s. So 103, which is going to be the left edge of my box, is like about right there. You know, close enough. The right edge of my box is going to be the upper median, which is at 139. That's going to be like there-ish. So there's the left edge and right edge of my box. Again, it's the lower median and the upper median. But the actual median is going to be a line. Where's 118? It's going to be like a line in the box. Okay? Then the whiskers are easy. We go out to 145, which is like right here exactly. Could be a dot, could be a line for your whisker tips. 91, about right there, and so that's where that whisker goes till. And there's pretty much your answer, except for the labels. Especially in this situation, it's probably best to label. That's 103, that's 118. That's supposed to be 139, and this is supposed to be 145. So that's the first example. This next one just needs to be put in order first before we do the median and stuff. So is 7 the... Nope. 5. Darn it. Well, unless I'm still wrong. Now it looks like it's going to go 5, and then 7, and then 8, and then 10, and then 10, and then 10. Looks like it. And then 10, and then 13, And you want to be sure, right? And then 13, and then 18, it looks like 18. And then anything in the 20s? Looks like there's 22. And then 30. So then next we have 30. And then a couple of 38s, it looks like. A couple of 38s. And then a 50 and a 51. So you got to put them in order to find the correct median. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's recap. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So hey, that's an even number. So what that means to me is that we're going to go 1, 2, 3, 4, 5, 6. And then there's going to be like another 6. So our median is in between the 18 and the 22. If you have to actually add those together and then divide by 2 to find the average, that's fine. But either way, just knowing what's in the middle of 18 and 22, it's going to be 20. Now, the lower half of the data starts here. The 18 is included in the lower half of the data. The 22 is going to be included in the upper half of the data. All right? So let's find the lower median now. How many numbers are here? 1, 2, 3, 4, 5, 6. So that means there's going to be like 3 of them, and then the other. So we're going to have to go in between the first 3 and the second 3, and whether you actually find a true average there between 8 and 10, or you just kind of know that it's 9, you still get 9. And so over here, what's in between 38 and 38? 38. You know, like what's the average of 38 and 38? 38. And so now we can, this is obviously going by 5s, so it looks like between 9 and like 38, lower quartile and upper quartile. I make my box, and then the 20 is the line in the box. And then it looks like my lowest number for my whisker is 5, and then my highest value is 51 for my right whisker. So you just need those 5 values shown on a box whisker plot. The very lowest number, the very highest number, the lower median, overall median, upper median. Example number 3. It's a stem and leaf plot. We covered this earlier in the video. Stem and leaf plot, if you write out all of the numbers, you don't have to actually write out all of these numbers, but I did, and it might help you, at least for this example, as we learn it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21 values. So to find the overall median, I think there's going to be like an actual number in the middle with 10 numbers on either side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like we're going in between those, and then we're going to have a lower half of 10 and an upper half of 10. So what's exactly in the middle of 60 and 62? I don't think we need to actually add them together and divide by 2 to figure out that it's 61. Now the lower half is 10 of them. So, right? And so it looks like there's going to be like, oh, wait. Oh, my gosh. I'm an idiot. I disobeyed my own strategy. Oh, my gosh. I'm sorry. I even said it myself. There was going to be 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The median was going to be like one of the numbers, and then another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a lower half of 10 numbers, an upper half of 10 numbers, and then an actual median in the middle. Oh my gosh. So the overall median was one of the numbers, and then the lower half of 10 to find just the lower median, we would go 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. So we would be going in between 50 and 51, which is going to be 50.5. Up here, 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. So we got to go in between 64 and 66, which is going to be 65. It looks like this is how I broke up our number line to span our numbers. And so 50.5 is going to be like there. 65 is going to be like there. We draw the box the best we can. The overall median was 62. So 62, 65, 50.5. It helps to label, especially when your number line is only like loosely broken up. 48. 48 would be like here-ish, you know? And then 74 would be out here. Okay? Now before we go to the back, right, I want you to notice something. You see how like this line is anything but in the middle of this whole box? So this median of 62, the line we end up drawing, definitely not exactly in the middle of that box. You know what I mean? Why is that? Because like that can totally happen, right? And look at these two whiskers. You see how this whisker is definitely, noticeably not as long of a whisker as this whisker, you know? That can totally happen, and maybe you can start to think about why that happens as we go to the back here. So let's quickly kind of go through these questions on the back. You are given, let's lock that down, eh? You are given a box and whisker plot that's about the ages of shoppers at the mall. So, I mean, think about what a box and whisker plot is telling you. You know, like what information is being revealed by this box and whisker plot, and to answer these questions. What is the mean? In other words, what is the average? Well, guess what? You can't tell. So it was, sorry, kind of a trick question. Maybe I tricked you. Because in order to figure out the mean or the average, you need to have the entire list of ages. Just seeing a box and whisker plot won't tell you the mean. Will it tell you the median? Yeah, right here. That line in the box is the median, which, so what would this be? Would this be 49? Or not? Maybe, look, looks like we're going by twos here. 42, 44, 46, 48, 50. Yeah, we're going by twos, so it's 48. This line matches up with 48, people, as best as you can tell, right? I mean, you can, yeah, I mean, it's a safe bet that this is lined up with that little notch. What is the mode? What number occurs the most? You don't know. You can't tell that just by looking at a box and whisker plot, right? But can you tell the range? Can you tell the range by just having a box and whisker plot? Yeah, because in order to figure out the range, you need to know the lowest number, 10, and the highest number, 66. Yeah, you can figure out the range based on what a box and whisker plot is telling you. So the range ends up being 56. How about the lower quartile? Do you know that? Where's the lower quartile? Sorry. Does the box and whisker plot tell you a lower quartile? Yeah, it's the left edge of the box. Looks like it's lined up with 32. How about the upper quartile? Well, wouldn't that be the upper edge of the box, which we can assume is in between 54 and 56? So 55. What is the inner quartile range? Well, remember, isn't that the difference between the lower quartile and the upper quartile? So we would do 55 minus 32 and get 23 as the interquartile range. And now we start to get a little tricksy with question H. So let's slow down. What is the best estimate for the percentage? The percentage. That is a key word right there, man. What is the best estimate for the percentage of shoppers that are younger than 48? 48? What the heck is 48? Look, here's 48. 48 is the median, the overall median. So how would you know the percentage of shoppers younger than the median? Well, think about it, people. The median cuts the data in half, doesn't it? The median is the middle number. It cuts the data in half. Now, sometimes the median cuts the data into two equal halves. Like in this case over here, it cut the data exactly in half. But in this case, it didn't cut the data into exact halves because, the lower half is like 10 numbers out of the 21. So this is a situation where it doesn't cut the data into two exact halves. I mean, shoot. What if I asked you here, what percentage of the data was less than 20? Because the median is 20. What if this number was also 20? What if this number was a 20? What if this number was a 20? That sort of affects the whole, it's not exactly half of the data is less than the median, but if you don't have the exact list, the full list of values, that's why this says best estimate. So I'm making this question kind of more complicated than it needs to be. Really, the median cuts the data in half, sometimes exactly in half. And so the percentage that you would say younger than the median, 50%. Maybe exactly 50%, but it's the best estimate, 50%. How about the best estimate for percentage of shoppers that are older than 32? Well, 32 was my lower median. All right? It's my lower median. Now, let's think about this. The median cuts the data in half. I don't care how big of a section this looks like compared to this. I don't care. It doesn't matter. It doesn't matter. Everything to the left of the median is like 50%, and everything to the right is like 50%. So if you cut this 50% in half again, isn't that pretty much making approximate, if not exactly, pieces of 25%? Like, what if you cut 50% in half? You're getting sections of 25%. So again, I don't care how big these sections look on the plot. This is a 25% chunk, at least approximately. This is a 25% chunk, at least approximately. So is this. 25%. So is this. So older than 32, that would be 75%. All right? Question J. Now they're telling us, all right, well, at least they're telling us now that there was 68 total shoppers surveyed. How many of them were older than 55? And 55 looks like it's the upper median. All right? Well, you can kind of start with a percentage, you know? The percentage that were older than 55 would have been like approximately 25%. And I'll go ahead and like, I'll do you one better. Since the number is 68, it's actually going to be exactly. Actually, you know what? I take that back. I tell a lie. You know? It might actually not be exactly 25%. Because what if you had a couple of shoppers, actually like a trio of shoppers that were like, I don't know. It could have went like this. It could have went a shopper that was 55, another shopper that was 55, and we went like in between those two shoppers to get the upper median. And so guess what? That would mean that it was an approximation. But that's the best we can do, an approximation. So we would do 25% of the 68 and do that and get 17.